Now, after that, I will just give a small introduction to the block driver. So, block driver, if you remember, right, till now, whatever we studied was a character driver, and the network driver we have not studied. So, whatever we studied till now is a character driver. Means all these drivers, whatever we studied till now, deals with the character streams of data. But what we will be discussing now is a category of devices which is capable of reading and writing in terms of blocks alone. This kind of devices is not capable of reading data in a byte stream. They have to write a data in one block, one chunk. It's fixed. You can configure to some extent, but whatever you do, you have to write the data in the blocks. Whenever you read also, you have to read in the block, and whenever you write also, you should write in the block. As such category of drivers which deals with the block data is called as a block devices. And most of the block driver, whatever you work, are the storage devices. Most of them. It's not necessary that block devices necessarily has to be the storage device, but most of them or majority of them of all your block devices are nothing but work dealing with storage subsystem. Okay, so now you would have a file system and you will have a VFS here layer normally, right? This block driver, the guy who would interact with the block driver is nothing but your file system. File system is the one who understands and who would communicate with the block driver. So well, I'll explain about the block driver, how this communication happens, but this is the flow normally happens. And your file system, your VFS will know about the file systems. And your file system will know the details about your block drive layer. So for example, in case if any of the application has to write any of the data on the disk, first it would always interact with the VFS. The VFS will get to know that, oh, this is something to do with the file system. It will do an handover to the file system. The file system will communicate with the block layer and perform the necessary transactions. Okay. So now, ultimately, all these block devices are meant to deal with the block of data, as I mentioned. Okay, so in Linux, at least the block size is 1 KB. Okay, so I think it is around, no, sorry, not 1 KB, it's 4 KB, around 4 KB it is. Okay, so that is a block size that is defined. Okay, but lower in the lower level, right, the hardware will have its different block sizes. I think mostly it will come in terms of 64, 128 byte, 256 bytes, or 512 bytes. I think majority of them nowadays comes with 512 bytes block size. Okay, so now, so we will try to understand what exactly this. I think all of us know the VFS is a generic interface. Using that, it will go to the file system, and the file system will have an interface to the block layer, and the block layer will have an interface to the storage subsystem. Okay, so now we will understand. So if you look at the storage diagram, right, at the eye level, how it looks like, right? And then, this is something. 1 minute, something is wrong here. Yeah. So this diagram will give a complete picture of this. Okay. So if you look at here, yeah. So let us have a look at it. Okay. So this is not the one. Yeah. So this is how it look like. If you look at any Linux storage subsystem, no, this is how it will have. It will have a VFS. VFS will have a detail about all the file systems. From the file system, no, the data will go to you something called as a block layer. From the block layer, ultimately it will try to access the corresponding driver via the device, whatever device nodes you have, right? It'll access via that, and that in turn will access the corresponding physical devices. That is how it will go. Okay. Now, if you see here, there is something called as a page cache also available here. So whenever the process wants to write the data, right, until and unless it wants to write the data to the files directly, right, file system directly, it'll go through the page cache. So data will be in the page cache. So always the data, it will maintain the cache of the pages. The data, whatever you're accessing, until and unless you want it to be done in the O direct. Okay. So using this, what will happen is the data will always go to the page caches. From the page caches, it will go to your VFS. From the VFS, it will end up into the block layer. From the block layer, it will end up into the corresponding driver. From the driver, it will end up to the corresponding physical device. This is how the flow would go. Okay. And one more thing, what you need to understand is the block driver will also have a scheduler. Block driver also will have a scheduler. Same like your process scheduling, right? Your IO request also you need to schedule, which is going to the block layer. Okay. So there is a dedicated scheduler for that. So we will discuss about that in the. Okay. So we will discuss about that in the next session. I will just, whenever we meet next time, right? I will explain you in detail what is the scheduler and what is the need for the scheduler. Okay. So the main thing is that you have to know that the block driver will have a concept of scheduler there also, because there is a reason behind it why it is required. So we will explain that. Okay. So that is required for the performance reason. It is not like a normal scheduler. There is a specific scheduling action that happens there, keeping some other criteria in mind. So we will look at it. So there is a scheduling done based on the deadline also, because you can assign the deadline and you can also put a scheduling, or else you can also do a scheduling based on other factors also. Okay. So we will look at what is the what kind of scheduling it will do, and then we can look at the other parts later. Okay.